Thank you.
Hey, thanks very much. It's an honor to be here. Last night, looking at all the booths and talking to people, it's fascinating what's going on. In many ways, being here for me is like seeing a pervasive computing or ubiquitous computing conference several years ago where things were talked about as pie in the sky. Now we have companies doing these things very seriously and fielding devices of various kinds and collecting data. So I like to organize my thinking about the future in terms of a trend towards and challenges of enabling true evidence-based healthcare. It's a phrase we hear a lot. Politicians use it all the time. It hasn't really happened yet. We now have large amounts of data being collected. Over the last 15 years, new machine learning algorithms for mining that data into predictive models and insights and discoveries, as well as taking predictive models in a decision analytic pipeline and generating actions, interventions, and those predictions and interventions can also apply to not just disease management and diagnosis and so on, but also to understanding which interventions will work, will have lift, will actually have benefit to patients. To date, I have to say that the bottleneck, critical bottleneck in this area is data. With everything we see being collected, it's a scarce, tiny faucet drip compared to what we can be gathering and collecting in hospital, at home, and in daily living via Pocket, per some of the comments we heard in the last panel from Jay and others. Opportunities are rife right now for collecting data also from the crowd, from online search logs and fora, where people discuss findings way in advance of what's being discovered by the clinical literature. Recently, we started doing a study of just looking at drug interactions, inferring drug interactions by looking at people searching on drug A and drug B and on symptoms of various kinds, and then working with some of our colleagues at Stanford on correlating these interactions with some FDA warning data that was only done for single diseases. And so where the logs are helping us to frame our attention on possible discovery about interactions and so on. So there's a glimmer of science in how we might use crowdsourcing, where we can raise that kind of evidence to the same level as clinical trial evidence someday through various things like Bayesian statistics. Let me just finalize my opening remark here by saying that there's some significant challenges ahead, even with the successful development of evidence-based methods. One is that several of these studies have already shown when you do this end-to-end pipeline of data to prediction to intervention, what gets recommended is patient-specific intervention, allocating funds on a per patient manner, such that, for example, this heart failure patient will bounce back within 30 days with a 40% chance over threshold. We fund a post-discharge support program for that particular patient, and not for another patient that remarkably looks very similar, except the evidence pattern is different. And subtle patterns in the evidence are being discovered by predictive models, which tell our decision analyses that patient A gets the treatment and patient B does not, will require us to shift in culture, I think, in terms of how we deal with notions of equality in healthcare, where equality is not efficacious nor good for for healthcare quality. Another interesting finding we've had, looking at a number of tens of thousands of heart failure visits from a database we're working with collaborators in the Washington Health Center in the DC area, is identifying physicians as being causative agents. For example, MD code 12893B is associated with a lift in cardiac readmissions. Or in a recent study we did of hospital-acquired infection, we all know somebody, everyone here knows people that have relatives or friends who've gone in for situation A and ended up with a nosocomial infection, but discovering this is the Dr. Typhoid Mary here. But really going through and weeding out what the causation is. Maybe this is just the attending in the ICU that's being labeled here and so on. So there will be a bunch of issues culturally and also institutionally in how these methods are applied. And those are just two of several. And I'll stop there.
All right. Thank you. Paul?
Great. So good morning. Thank you, everyone, for coming. I agree completely with what Eric said, starting with the point that the ability now to collect data from a variety of sources, whether it's this, these personalized sorts of things that you see here, or whether it's the sorts of things that you get online, is just amazing. And the ability now to begin to mine those sorts of data, as suggested, sort of evidence-based medicine, and just sort of trying to generate evidence from sort of found data, whether you think of it as crowdsourced data, whether you think of it as personal data, medical health record data, anything that you get online is just fantastic. But I kind of want to take that thought and I want to kind of move it to the next level. So there are kind of two things to that. First, rather than thinking about data, I really want to think about models, and more specifically, I want to think about simulations. Okay, so rather than taking data as this kind of given, I want to figure out how can we go beyond the data to think through the consequences of specific interventions, or think through situations that might not have happened before, right? The kind of stuff you can find in the data is only as good as the data, right? But we know about how things work, and we can simulate how things work and play out consequences of them. That's the first point. So moving from data to models and simulations. The second point is to think about not just health as, traditional health data, the kind of stuff you collect in the glucose meter and whatnot, right? But think about health as a complex system of interactions across a wide range of what you might call life systems or life course systems. There are a couple of popular terms here. Education is important. Transportation is important. Food sources are important, right? Take a problem, any of your basic chronic diseases like obesity. What influences obesity? It's really easy to say, eat less, exercise more. We all know that it ain't so simple, right? How do you, we had the talk this morning on persuasion. How do you begin to persuade people to actually do that? Well, it isn't actually as simple just as persuading people, right? There's advertising, there's education. It's not enough for Michelle Obama to say, eat good food, right? It's just not enough. You got to have access to good food. You've got to be able to get to where the food is. The food's got to be able to get to you. You've got to be able to receive those messages. And that's just a small piece of it. So when I think about healthcare and I think about modeling in healthcare, I'm not really thinking about healthcare, I'm thinking about health. I'm thinking about the larger set of systems that interact together. Again, think about obesity, think about all of those things that have to come together when we try and have an intervention like, no more soda in the vending machines in schools in New York. What are actually the consequences of that? We could think about that from a modeling and simulation perspective. It isn't as easy as thinking about it from a data perspective, and it isn't as easy as thinking about it from a healthcare alone perspective. So I think in the future what we're going to see is more use of models and simulations, not just in this narrow band of medicine and healthcare delivery, but models and simulations in a much broader context around health systems and the set of interactions around all of the systems that people come in contact with. And we can start to do that today, and that's what we're doing at IBM.
Hello to all of you. I'm Ronnie Zeiger, at R. Zeiger, as some of you are lovingly referring to me. I think that there's a couple of spheres of people and behaviors that are beginning to intersect in really exciting ways. One of them are the quantified self folks, and many of you are aware of that. Exciting movement, I think, is a fair description of people who are measuring everything, checking their blood sugar with no known diagnosis of diabetes, counting every step that they take, every minute that they sleep or awake, and asking questions about that and sharing their data with each other, and really, in some senses, defining the next generation of clinical investigation in a way that I think makes a lot of us uncomfortable. Another sphere or end of this spectrum is the fact that a project which I had the fortune of being involved in, as an example, Google Flu Trends. A couple of engineers at Google had at the time I thought, silly idea of trying to measure or estimate in real time how much flu is going on where by looking at search logs. and turned out that they were right and they could do it.